Hi, my name is Alberto, and I'm currently developing a tour-based strategy game made with Unity. In this devlog, I wanted to show you briefly our first visual upgrade. As you can see, we have decided to go for a low-poly hexagonal grid art style. If I click on one of our unit groups, you can see that the hexagons that are not in range become darker. Let's take a look on how we achieve this effect. First of all, we create a color palette with the different color gradients. Then we can assign these UVs to our models. We can choose the cells that we like more to achieve different color effects. What is interesting from this approach is that we can later on change the colors and everything will change accordingly. The other interesting thing is for visual effects. As we will see, we can darken the colors of this grid by just moving the UVs down. In-game, we are going to make use of our hexagrid rendering system to render all the hexagons in screen. In order to improve the performance, what we are going to do is to combine all different hexagonal meshes in one single mesh, and we are going to render this mesh in a single draw call. In order to achieve the darkening effect on the hexes that are not in range, what we are going to do is to move the UVs to a darker cell in the color palette. For that, we need to store all the UVs that are in our combined mesh and the information of the indices of each individual hexagon that has been combined in this mesh. If we go down to the loop where we've been combining the meshes, we can easily get the data of the indices by recording the start index as the current count of UVs and the final index as the current count plus the length of the current mesh that we are combining. Now, if we want to darken the hexes, what we want to do is to move down in the color palette gradient to the lower cells. If we go back to the code and we look in the method hide all hex meshes, what we're going to do is to copy all the UVs, and then we're going to modify this Y value of the UV by shifting it down a number of levels which correspond to the cells by applying this multiplication here, which this value corresponds to the normalized size of these cells. And that was it for today. Thanks for watching, and we'll see you next time.